In the previous session, we will discuss about constant velocity type of motion, in which case the particle is said to be moving with the constant velocity. We have written one note that you should remember, that whenever the particle having magnitude of velocity and direction of velocity both remain same, then only the particle is said to be moving with the constant velocity. We have seen some examples in the previous session that here both magnitude and direction of velocity both changes. That is why it is non-constant velocity. Here direction changes, here magnitude changes. So if one of the characteristics is changing or both are changing, so obviously these are non-constant velocity. Non-constant velocity are also called as changing velocity, and the most appropriate word is accelerated motion. Okay, so in our syllabus we will have only such type of accelerated motion examples in which the magnitude changes, not the direction. And if both remains constant, in which condition both remains constant? Magnitude should be constant as well as direction should be constant. Then only the particle's velocity is said to be constant velocity motion. Based on these, on page number 102 of your textbook, you have some blue color questions as well as some examples to solve. Look at blue color question on page number 102. Blue color question number 1. What is that? Distinguish between speed and velocity. Distinguish between speed and velocity we have seen in the previous session. I have written 4 different points. Speed means distance upon time. Distance traveled in unit time. Definition you write first, then you write the formula. Then speed is a scalar quantity, velocity is a vector quantity. Speed always remains positive. Velocity can be positive, negative or 0. So 4 points of difference are enough when you have been asked such question in exam. Second, under what condition or conditions is the magnitude of average velocity, means magnitude of velocity of an object equal to its average speed? In which condition both are same? So the only condition is the path should be straight. Whenever the path of motion is straight, in that condition velocity and speed having the same magnitude. Okay. What does the odometer? What does the odometer shows? I told you in the previous lecture that odometer shows the distance traveled by a particle. So the answer for that question is distance traveled by the particle is shown by the odometer. What does the path of an object look like when it is in uniform motion? Most of the students misunderstand that. First of all, what do you mean by uniform motion? Uniform motion means uniform speed. Here I have told you, uniform motion means uniform speed. The speed is constant, not velocity. Uniform motion doesn't mean uniform velocity. Uniform motion means uniform speed, and speed can be same in any type of path. Look at this path. Here the path is like this. The path can be like this also. But if the value of speed remains constant, that is uniform motion. So in uniform motion, the path can be of any shape. Yeah, if the question is like this, that what will be the uniform velocity? Uniform means constant, no? Uniform word means constant. But if it's uniform velocity, then the path should be straight. But here the question is uniform motion. Uniform motion means uniform speed. And speed can be constant on any type of path. So here the question, you have been asked that what does the path look like when the particle is having uniform motion? So what you will answer here? The path can be of any shape. Means there will be no definite path when the particle is moving with the uniform speed. Next example, next question number 5. During an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of spaceship from the ground station? The signal travels at the speed of 3 into 10 raised to 8 meter per second. It's numerical. Let me draw the condition. Please take out your textbook if you don't have and read the question carefully. During one of the experiments, signal from the spaceship. Consider here is the Earth. Here is the station on the Earth. Okay, and here is one of the spaceship. That spaceship sending some signals, and that signal reached to the ground station in 5 minutes. So the time required to travel this distance is 5 minutes. Now the question is, what was the distance of ground station from spaceship? Means this distance we have to find. Distance to find. Okay. The signal travels at the speed is given, speed of 3 into 10 raised to 8 meter per second. These are the given information. Very easy sum. Speed is given, time is given, distance is missing. Okay, but take care. Here the speed is given in terms of meter per second, and here the time is given in terms of 5 minutes. So first of all, you convert this minute into second. So 1 minute means 60 seconds. So 5 into 60, it is 300 seconds. Now according to formula, speed is equals to distance upon time. Therefore, what is missing here? Distance is missing here. So let us make the formula of distance from this, transfer this t here in the multiplication. So distance s is equals to v into t. Therefore, now put the values and got the answer. S is equals to, what is v? V is 3 into 10 raised to 8. 3 into 10 raised to 8 into t, and t is 300. So therefore, S is equals to 3 into 300. So 3 3s are 9. It is 900 into 10 raised to 8. So now 2 zeros are here. So 2 zeros means 10 raised to 2. And therefore S is equals to 9 into 10 raised to 8 is already here. And 10 raised to 2 more. So it is 10 raised to 10 meters. If you want to write your answer in terms of kilometer, 3 zeros should be reduced from this. So 9 into 10 raised to 7 kilometer. Whatever the way, you can write your answer. So you have to prepare the formulas, definitions, units, then you can solve any type of problem. Now just below that blue color question, you have example number 8.2. Let us solve it. Please read the question, everybody. Example 8.2, page number 102. The odometer of a car reads 2000 km at the start of a trip. The odometer shows the distance traveled. So odometer of a car reads 2000 km at the start of the trip. Means when the journey starts, already the reading was 2000 km and 2400 km at the end of the trip. So I think the trip is of 400 km or not, obviously. So distance traveled is 400 km. If the trip took 8 hours, okay, so what was the initial reading of odometer? Initial reading of odometer is 2000 km. Can we write xi for that? You can. Xf means final position is 2400 km. So we can say the distance traveled is xf minus xi. So it is 400 km. No need, it is not always necessary that you should write such type of data. If you got the distance 400 kilometer from the question only, then you can directly write like this, that S is equals to 400 kilometer and it took 8 hours to complete the journey. Now the question is, you have to find the average speed VAV in terms of meter per second as well as kilometer per hour. We know, I think if you remember, that whenever you want to convert any kilometer per hour to meter per second, you have to multiply that number by 5 upon 18. And reverse thing, that if you want to convert meter per second to kilometer per hour, you have to multiply that number by 18 by 5. But here we have been given distance in terms of kilometer, time in terms of hour, so we can easily find average speed in terms of kilometer per hour. Total distance upon total time. Total distance was 400 kilometer and upon 8. So VAV is equals to 8 5s are 40, so it should be 50. So it is 50 kilometer per hour. Now you convert this 50 kilometer per hour into meter per second. So to convert that 50 kilometer per hour into meter per second, you multiply that number by 5 by 18. So it is 5 upon 18. 2 9s are and 2 25s are. 25 5s are 125 upon 9. 125 upon 9 is nearly 13.88 means 9. 13.9 meter per second. That's all. This is your answers. Next example number 8.3. Look at this. Usha swims in a 90 meter long pool. Swimming pool. So the length of the swimming pool is 90 meter. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and average velocity of Usha. So the condition is like this. Example 8.3 on page number 102. Usha swims in a 90 meter long pool. So the length of the pool, consider this is a swimming pool, and the length is 90 meter. So Usha starts swimming from this end A and ends at B. So Usha starts swimming from A. It is given that she covers 180 meter by traveling from A to B and back along the same point A. So 90 meter and another 90 meter. So she travels 180 meter in 1 minute. So can I make a list like this? The distance traveled is 180 meter from one end to other and back along the same straight path. Distance. Now, if you see that she starts swimming from A, goes to B and come back to A. So what is the displacement? Can I say displacement here is 0? Because she starts from A and ends at A. So no change in the position. So displacement is 0. And now the question is, you have to find average speed and average velocity. So can I say average speed is equals to, average speed is total distance upon total time. So total distance is 180 meter. Okay, total distance is 180 meter. And what time it takes to travel this? The time required by Usha is 1 minute, and 1 minute means 60 seconds. So distance is 180 meter and time is 60 seconds. So 180 by 60. So 0 cancelled. So it is 6 3s are 18. So 3 meter per second. So this is average speed. But what about the average velocity? but we don't have any displacement here. So average velocity means displacement upon time, but the displacement is 0 and upon time is 60 seconds. So the answer will be 0 because no displacement, so no velocity. Nice question it was. Same type of examples are given in your exercise. Page number 112. See, first we cover all these examples of speed and velocity, then we go for the acceleration topic. Page number 112, please take out. Question number 1, exercise. Page number 112, exercise, question number 1. An athlete, read that question please. Look at here if you don't have your textbook. If you have, then read from that along with me. An athlete completes one round of a circular track of diameter 200 meter in 40 seconds. I think we have solved this numerical in the previous session, but then also let us repeat it. One of the athlete completes one round of a circular track of diameter 200 meter in 40 seconds. So this is a circular track and diameter for this track is given as 200 meter. So radius is 100 meter. Okay, so that athlete completes one circular round in 40 seconds. He keeps on jogging for running for 2 minutes 20 seconds. 2 minutes 20 seconds means total time. Total time of running is 2 minutes 20 seconds. So total time is 2 minutes means 120 seconds, 120 seconds and 20. So total time of running is 140 seconds. He requires to complete one circular track round 40 seconds. So 40 seconds, 40 plus 40, 180, 80 plus 40, 120, 120 and half here. So after 140 seconds of total running, he will be here at the opposite end of the initial point. If he starts running from A, he will complete 1, 2, 3 circular tracks, 3.5. He will end its motion at point B. Now the question is, what will be the distance and displacement covered? So distance means length of the path. So he has covered 3 circumference and a half. So 3.5 means 7/2 circumference distance. Okay, so 2 will be cancelled. So total is what? 7 pi r. 7 into 22/7 into r. R is given as 100. 7 cancelled. So distance travelled is 2200 meter. And now what will be the displacement? Displacement does not depend on path. It is a straight distance between initial point and the final point. Initial point is A and final point is exactly diametrically opposite point. So I think the displacement is nothing but the length of the diameter. And length of the diameter is 200 meter from A to B. We have to mention the direction while writing the displacement also. These are example already we have discussed. Let us move faster without wasting time. Question number 2. Read that question. Joseph jogs from one end A to the other end B of a straight 300 meter road in 2 minutes. So Joseph is jogging on the straight path. Let us draw this type of straight path. So Joseph jogs from point A. Look at the question. Please look at the question from your textbook. Joseph jogs from one end A to the other end B of a straight path of length 300 meter given. So this and time required to complete this is given as 2 minutes 50 seconds. So going from A to B on the straight path, Joseph required 2 minutes 50 seconds. Okay. Now further question. Please look at the book. And then turns around and jogs 100 meter back to point C. Now from B he again comes back on the same path, but only 100 meter and stop there. At point C, this distance is only 100 meter. And he required what time? 1 minute to come from B to C only. Now the question is, what are the average speeds and average velocities in jogging from A to B and from A to C? The two cases are there. First case A is from A to B, and in that case you have to find average speed and average velocity. Average speed and average velocity, both you have to find. Now what do you mean by average speed? Average speed means total distance upon total time. So when you go from A to B, just the first case is what? A to B. So first of all tell me, what is distance traveled? So from A to B, so A to B distance is given as 300 meter. So distance is 300 meter. What is displacement in A to B? Because the path is straight, the displacement also will be 300 meter from A to B. Just I am mentioning the direction. What is the time required to complete this A to B distance? It is given in your question that the time required is 2 minutes 50 seconds. So 2 minutes means 120 seconds. 120 seconds plus 50 seconds. So it will be 170 seconds. And now the question is, you have to find average speed and average velocity. So average speed is total distance upon time. Total distance is 300 meter. Upon time is 170 meter. 0 cancel. 30 divided by 17. 17 ones are 17. Then 13 left. 17 8 or something like this. So nearly 1.8 meter per second. Okay, near about that 1.7 or 1.8. You can do the division by yourself. Now what is the average velocity? Average velocity means displacement upon time, and displacement is also 300 meter and time is also same. So everything looks same, but the only difference is what? Only difference will be 1.8 meter per second from A to B. So because velocity is a vector quantity, we have to mention the direction. So this is of first case A to B. But now the second case, in the same question, you again find average speed and average velocity. In the second case from A to C. Now what is from A to C? A to C means, look at here, A to C, the particle goes from A to B first and then C. So when you think about the distance, distance will be AB distance plus BC distance. So 300 to go from A to B and then one more 100. So 300 plus 100. So it is 400 meter distance. So distance here, let us make a list of distance, because distance depends on path. Particle directly not going from A to C only and not stop there. Particle first goes to A to B. Joseph travels from A to B first and then comes back. So 300 plus 100. So distance is 400 meter. What is the displacement? Displacement does not depend on path. It depends on final and the initial position. So initial position is A and final is C. So I think this straight distance is only 200 meter, because 300 meter is from A to B. This 100 meter comes back. So I think the displacement is 200 meter. Direction is from A to C. Now what is the time required? Time 2 minutes 50 seconds to go from A to B. And from B to C it again takes 1 more minute. It is given in the question. So total time is 3 minutes 50 seconds. So 3 minutes means it's 180 seconds and plus more 50 seconds. So it is 230 seconds total time. And now you find the average speed. Average speed means total distance upon total time. Total distance is 400 upon 230. 0, 0 cancel. 23 ones are 23. It's 40 divided by 23. 23 sevens are 23 sevens are 161. 9 left, 0. It will be 73. So 1.73 meter per second is the average speed. But now what is average velocity? Average velocity means total displacement upon total time. Total displacement is 200 upon total time is 230. 0, 0 cancel. It's 20 divided by 23, so it will be less than 1 it will be, because 0 point something here. 23 8s are 184. 16 left, 0. So it will be 7 like that. So 0.87 is enough for us. 0.87 meter per second from A to C. This way we can calculate distance and displacement. One more question, number 3. Next one. Very tricky and very important also. Look at here. Abdul while driving to school. Please everybody read the question carefully. Abdul while driving the school computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 40 km per hour. Now what is the average speed for Abdul's whole trip? The condition is like this. Again, you keep the question in front of you. I am drawing the condition. Abdul while driving to school. So Abdul is going to school from home. Let us consider here is his home and here is the school. Consider this is the route to go to school. This is the path, you can say. He noted that when he go from home to school, his speed was 20 km per hour. Okay, going from home to school, his speed was 20 km per hour. On his return trip, look at the question, on his return trip along the same route. So when return trip means again coming back from school to home. Okay, so he is following the same route. He is following the same route, and while returning back, traffic was less. So he comes somewhat faster, and the speed he noted 40 km per hour. So when going from home to school, so the first part of the journey is from home to school and second part of the journey is from school to home. So first speed and going from home to school was noted as 20 km per hour and second speed he noted as 40 km per hour, and the question is you have to find VAV. We know that VAV means average speed is total distance upon total time, means S1 plus S2 upon T1 plus T2. But here S1 is not given, S2 is not given, the distances are not given, time required going from home to school or school to home is not given. And here we have to understand one thing, the informations are very less, only the two different speeds are given. But one thing is very important given here in your question is that while returning, second line, on his return trip, see look at here, on his return trip along the same route. So this indicates same route. Same route means the distance traveled in the first part and the distance traveled in the second part are same. Just assume that if he is not following the same route, he is going from some other path, for example from here, then the distance will be different obviously. But here it is given that distances in both the path. Here, can I write like this? Here, Abdul is following same route in both the parts of motion, therefore distances are same. So can I say S1 is equals to S2? So when distances are same, if you remember, when the distances are same, we have one formula to find the average speed. If you remember, let me show you where that page is. Here, when the distances are same, if S1 is equals to S2, VAV is equals to 2 V1 V2 upon V1 plus V2. So I think here, can I say VAV can be calculated as 2 V1 V2 upon V1 plus V2. We have V1 and V2 both. Put the values and find the answer. That's all. VAV is equals to, what is here, 2 into, what is V1? V1 is given as 20. What is V2? It is given as 40 upon V1 is 20 plus 40. So here 4 2s are 8, 8 2s are 16 and 2 0 1600 upon 40 plus 20 60 only, 0 0 cancelled, 2 3s are and 2 80s are. Yes. So it is 80 divided by 3. 80 divided by 3, 3 2s are 6, 2 left 0, 3 6s are 18, 2 left 0, so it will be 26.666. So we can write 26.67 meter per second is the average speed of Abdul's whole trip. If you don't know this formula, then you cannot solve this question easily. Yeah, we have some other complicated way also. We have to assume the distance be x and so and the long process we have to follow. But here it's very easy that if you strike this, if you got the strike that here the distances are same, then we can use this formula and the 1, 2 and 3 steps and the answer is here. So this is all about distance, displacement, speeds, velocities, constant velocity, and a new topic will be acceleration, means change in velocity. That we'll see in the next lecture. Till then, you solve all these numericals which we have done. Best of luck.